Hello chemists, we're going to be talking about electron configurations today. First thing to talk about is what is an electron and where do we find them. They are small negatively charged particles that are found around the nucleus of an atom. This is a carbon atom, so those are arranged in two shells. You've got your inner shell with a maximum of 2. You've got your outer with 1, 2, 3, 4. Drawing obviously not to scale, but it will do for now. To refine that definition of what an electron is, let's talk a little bit about what the different locations of atoms mean. Well, they're arranged around the nucleus in various, we've been calling them shells so far. Shells are energy levels. Basically, the further away an electron is from the nucleus of the atom, the more energy it has. So that you can also call these shells energy levels. So energy level means the same thing as shell, which is another way of saying a group of electrons with a similar amount of energy, a similar distance from the nucleus. So electrons in this shell here will have a similar amount of energy, and electrons in this shell here will have a similar amount of energy. However, these shells actually have sublevels. They have subshells. Either term is correct, you can call them sublevels or subshells. And those subshells are broken up into things called orbitals. And those orbitals do not have a nice shape like those rings we're used to seeing. They are much messier. But they can be broken up into 4 different types, each orbital containing 2 electrons. So you've got 4 different types of orbitals. You've got the type of orbital called an S, that means sharp. You don't really need to know what they mean. I'm just telling you where the letters came from. P stands for principal. Diffuse, D. Sorry about my handwriting. And F for faint. So your orbitals are broken into categories called S, P, D, F in that order. They're named after what they look like. I'll show you some pictures of them later. The S orbital has, the S shell has 1 orbital. The P has 3. The D has 5. And the F has 7. We don't really deal with F orbitals at level 3, but it does have 7 subshells in it, 7 orbitals. Okay, so those don't fill up in the order you might think. They fill in an order which we can see here. So first you fill your 1s orbital, then you fill your 2s. First you fill your 1s, then you fill your 2s, then you fill your 2p, and then your 3s, and then your 3p, and then your 4s, and then your 3d, and then your 4p, and then 5s. It will eventually look like this. 1s, 2s, 2p, 3s, 3p, 4s, 3d, etc., etc., etc. As you can see following this diagram right here. Don't worry, that will begin to make a lot more sense because it's always the same. So you've got that order there. And they fill in order, that order that I just mentioned, 1s, 2s, 2p, 3s, 3p, 4s, on and on. As you fill each one of those orbitals, you move on to the next one. You can see that the periodic table is arranged like that as well. So hydrogen and helium both have only 1s orbital. And then as you go across, you've got your 2s over here on the left. Over here on the right, you've got your 2p, 3s on the left, 3p on the right, 4s, 3d in the middle, and then 4p. And as you get further down, then you start adding the s's. So it's arranged this way because of the orbitals. When you fill it in, you need to follow something called the Pauli exclusion principle and Hund's rule. You like these names? Oh yeah, the thing I just talked about was called the Aufbau principle. You probably saw that from the head of the previous slide. You don't need to know these names. They're just named after the guys who invented them, or discovered them rather. They weren't invented, they were discovered. So the Aufbau principle is you fill them in order. Pauli's exclusion principle means that each orbital gets 2 electrons. 2, 2, 2, 2, 2, 2, 2. So as you can see, if something fills up all the way to the 3p orbital, it's got 2, 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. And you could find out for me which element has 18 electrons pretty easily. Okay, So when you fill them in, you don't just slap electrons in however you want. There is an order that you fill them in. And the order depends on the spin of the electrons. Electrons have two different types of spin. Spin is a quantum effect. And we don't need to know a huge amount about it except that it's got two directions. We indicate these directions with these little kind of half arrows, one pointing up and one pointing down. That doesn't mean the electron is spinning up or spinning down. It's just a way of indicating that they have opposite spin. So each orbital has one up and one down. We usually put the up on the left and the down on the right. That's just the way that they go. But you don't fill in one and then move on to the next and then move on to the next. Instead, what you do is you fill in all of your ups and then you go and you fill in all of your downs. So then you've got a full orbital. So if we wanted to fill in, say for instance, this is the sound of me pulling out my periodic table. If you wanted to fill in, let's pick copper. No, let's not pick copper. Copper is an exception. We'll get to it later. Let's pick zinc. Zinc's nice and not an exception. Zinc has Zn 30 electrons. So first we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So all the way up to 4s. So that means we're going to fill them in that order. So first we do here, then we do there, then we do all of our ups, then we do all of our downs, up, down, up, 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 down, down, down. Then you do 4s because as you can see from this table here, 4s is a lower energy than 3d. So you do 4s before 3d, up, down, and then what am I at? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that is zinc. If you had a zinc ion, say a Zn2+, you would simply erase electrons in the opposite order you added them. For the most part, there's some exceptions there as well. We'll get to them. And the opposite for negative ions, you add them. And that's all I'm going to get into today. I see I'm a little bit over time, but y'all will have to forgive me. Smash that like and subscribe button. I will talk to you soon.